Hi friends, good morning. Today we are going to start with a new section of general mechanics, that is central force and Kepler system. Right. So before coming to that, we can discuss what is a central force. Generally you seen, suppose any force which acting towards the center, suppose for earth attracting any body with its towards its center with a force mg, right? Or we say this is m, this is capital M, then m into this g I can write as gm by r square, acceleration due to gravity of earth, then that is gmm by r square, right? That is the gravitational force acting on any body. We studied in lower classes, right? See, this is the height h and this is the radius r, but r plus h we taken as r only. Why? Because h is very small, right? So suppose the body on the surface of earth, so we can take this r as the radius of earth as the distance between the two body, because this body radius is very negligible compared to the earth radius, right? All right, so that is a central force. Now what are the properties of a central force that we need to know, right? For a central force, what we studied in lower classes, for a central force, for example, see a body, right? It is bound to this earth. Why? Because it is bound, it has a gravitational potential energy due to attractive force, right? If u is the gravitational potential energy, right? See, suppose you consider any body on the surface of earth, what is the potential energy you studied? Suppose it is at a distance x from the surface of earth, then potential energy here what we studied, mgx. Am I right? Mgx. Now what we studied in lower classes, force is equal to gradient of this potential energy, right? Gradient of this potential energy, that means you can prove that minus dou by dou x of, right? Suppose you put a potential energy u as mgx, this u I replace with mgx, right? Now minus mg you can take out, dou by dou x of x, that is what, 1, right? Then minus mg, what is mg? Mass into acceleration due to gravity, that is force only. So that is equal to minus mg is the force acting downward, right? With its symbol it is correct, it is acting downward, negative. So this f is equal to, we are getting here by negative gradient of potential energy, right? So if any body under central force, its potential energy we can write as, the force acting on the body in terms of potential energy we can write as, right, minus dou u by dou x, right? We can write. Now for a conservative force, what is the condition? Del cross f is equal to 0, right? We coming back to the vector analysis. In mathematical methods in physics, we studied what is del cross, right? What is del cross? See, del cross means it is a curl. Suppose divergence means, suppose you consider a positive charge, electric field always diverging away from it, okay? It is not rotating like this, right? It is electric field is always diverging, right? So divergence of electric field not equal to 0. You studied rho by epsilon 0, electrodynamics we studied, that is another case. But something is revolving around, for example magnetic field, del cross b what, not equal to 0, mu 0 j. Why? Magnetic field is rotating around, right? Around a circular current carrying loop, it is rotating, right? So del cross b not equal to 0. But del cross e equal to 0 means, what is its meaning? Electric field is diverging only, not rotating. That means we say electric field is conservative. Electric field is conservative. Can I say conservative? Right. Similarly, this gravitational force, you think. This force is acting towards the center. Not not a circular force. It is not a revolving force. It is acting towards the center. That means it is a conservative force. That means a del cross F is equal to 0. Right. If del cross F is equal to 0, in mathematical methods in physics, what we studied, a curl of divergence of a quantity only 0. Right? Then F must be gradient of some function. That only I told F is equal to minus dou u by dou x. Force is the negative gradient. Then only curl of a gradient of function only 0. Then force must be, that is a gradient of a function as per vector theory. Right. So that knowledge is very important. Right. What is a conservative force and what is the central force? Now we can come to some properties of this. Right. See, based on that we can say torque. Right. Torque and angular momentum of the system. Right. See, what is torque? Torque is equal to R cross F. Right. Now torque is equal to, what is R cap? What is F? F already we studied. F is equal to minus dou u by dou R, negative gradient of potential energy. But that force direction is what? It is radially inward. For example, one body on the surface of earth, this is a earth, one body is there, that force is acting radially inward. Right? Through radius vector only it has come to the center. That means R cap only. Now R minus I can take out, dou u by dou R. This R also I can take out. Here what is 2 vector R cap cross R cap? What is that? Same vector cross product is 0. That means torque is equal to what? 0. Torque is equal to 0. Torque 0 means torque is equal to, you know, right? Torque 0. Torque 0 means what we studied. Torque is equal to rate of change of angular momentum. Alright. You studied linear force F is equal to, from Newton's law, dp by dt. In previous lectures, Newton's law we seen, Newtonian mechanics. So rate of change of linear momentum is the linear force. Then rotational force, what? Rate of change of angular momentum. In central force problem, what we studied? Right. Torque is equal to dl by dt. That is 0 we proved. 0 is equal to dl by dt. That means L is equal to a constant. Right. L is angular momentum. We used another vector J. Right. J is equal to constant. Okay. J is equal to a constant. Right. Now you can have a lot of ideas from this. See, suppose a body R dot J. What is the R dot J? Suppose a body, right? Angular momentum. Suppose a body is rotating under a central force. Okay. Suppose you can consider, say, one electron. See, one nucleus is here, positive charge, one electron revolving around. Right. Now look here. This is the radius vector to nucleus. Okay. What about the angular momentum direction? See, angular momentum we studied as R cross P. Right. R cross P. In lower classes we seen angular momentum is equal to R cross P. So one body is moving. This is the momentum direction. Right. Mass into velocity. So linear velocity tangentially in this direction. So momentum is in this direction R. Then R cross P direction, that also we studied. It is perpendicular to both R and P. Then R and P direction what? 90 degree. Angular momentum, suppose you draw, see, one perpendicular to this right? One fan is rotating, the axle of the fan only angular momentum, then only it will be perpendicular. Suppose one body rotating, this is radius vector, this is momentum vector, this is radius vector, then what is the vector perpendicular to both r and p? R cross p direction we studied as r cross p direction is perpendicular to r, perpendicular to p. Then it should come like this outward, then only it is make 90 degree with p vector, 90 degree with r vector, 90 degree with p vector, 90 degree with r vector. Am I right? So r cross p is perpendicular to both r and p. That means angular momentum. Then what I can say, r dot p 0 because angle is 90 degree. R dot p means rp cos 90. Cos 90 is 0, right? So r dot p is 0. Then what you understand, r perpendicular to L, that means J. Here they used the letter notation J. Alright, you understood everything. R dot J, that is r dot r cross p, that also 0. Why? Because so here r dot L they are represented as, so r is perpendicular to J, so that is 0, and J is r cross p, right? That also 0 because J only they replaced. This r perpendicular to J, right? So this all knowledge we required, right? So in coming classes we need to frame a differential equation corresponding to central force, right? So we discuss more about it during the next class. Thank you.